Hey guys, gonna finish up here questions L through M. Um, questions L is asking us to find the position of the particle when it's at its highest point. All right, and this is really tough. You got to find the position at the different times. It's almost easier to kind of think of this in a in just kind of an arithmetic sense. If we started at 5, because it says we start at 5 at time 0, where's the position at time 5? This says we went up 6. So at time 5, we are at 11, which is what we just found in the question before this one. Then we go down 3 because it says, this is 3. There is 3. So it goes from 5 to 8 to 11. I'm sorry, from 5 to 11 to 8. And then this last little thing from 8 to 9 says it's going up 1. So we're going from 5 to 8 to 11 to 9. So what's the highest point? That's right, it's 11, the highest position. Okay. This actually says when is at its highest position, so you got to make sure you answer the question. That would be t equal 5. But how did you use this? Well, you've got to show it besides just going 5, 11, 8, 9. And what we're going to do is use the extreme value theorem. Alright, that sounds rough, but it's actually not that bad. The extreme value theorem tells you when you can find your extreme values. And it says your extreme values are going to occur either at your endpoints or at your critical numbers. The endpoints that we have, I'm going to just cover up M and N. The endpoints that we have are at time 0 and time 9. We need to find the position at these two values. The position at time 0 is at 5 because that is given. Okay, right there. Okay, the position at 9 is, and it doesn't matter the order you do this, but the position at 9 is going to be your starting position plus this integral of your velocity from 0 to 9. This is basically, remember, this means position change, and we did this in number 1, where we actually explain what this is. So that position would be 5 plus 6 minus 3 plus 1. This is just like number 1 and number 2 from the walk the line with the bug. So 11 minus 3 is 8, 8 plus 1 is 9, and that's what we got right here. At time equals, our critical numbers are where the velocity graph is 0. That's time 5 and time 8. So at time 5, we're going to have the initial position, 5, plus the integral from 0 to 5 VT. We actually did this problem above. I can't remember which one it was, but it's basically 5 plus 6, which would be 11. You actually don't have to do the one at time 8 because if you looked at this, this is a relative minimum because a V changes from negative to positive. So if you notice this on a free response, you actually wouldn't get credit for doing this, and you wouldn't get credit if you didn't do it because it's a relative minimum, but we'll go ahead and do it because we got it. And it would be 5 plus 6 minus 3 because 6 minus 3 is the up 3, up 6, down 3. And that would be 8. All right? So the maximum position is 11. You got to make sure you read the question because it says when is the particle at its greatest, so that would be time equal 5. If it did say the minimum, what is the minimum? You may be tempted to say 8, but it's not. 8 would be a relative minimum because it changes from negative to positive, but the actual minimum distance, the lowest that bug is at 5. That's why you got to test your endpoints, even if it's given to you. Okay, and if that was the question, you would have to say 5, and you would have to show this to justify it also, while that beginning is that. So you get tons of points on this. This is like a 5-point free response question, just this L is. So that's pretty huge. This is the extreme value theorem. Just says test your endpoints. We'll put EP for endpoints if that's okay. And right here, critical numbers, C and then number. Okay? Critical numbers are where it touches the x-axis. You could include 0 in that if you wanted to. but we already include 0 right there, so that's okay. Alright, now we're on to M. And in fact, I'm going to put this on the same screen. It says how many times is a particle at position 7. Basically, our justification right here is exactly what I've done. So this work right here, the position went from 5 to 9 to 11 to 8. So where did it hit 7? The only time it hit 7 is from, if I put this in order, when we went, would be from 5 to 11. You don't hit 7 again over here. Okay? So you'd almost have to go T, if I would have put this in order, that might have been a better thing to do. At T equals 0, my position was at 5, at time equal 5. That's this right here. My position was at 11. At time equals 8, my position was at 8. And at time equals 9, my position was at 9. Just copying this over. So the only time I'm hitting 7 is right here. I think what would have been a better question, it said, how many times does a particle hit 8.5? Think about that for a second. How many times would it hit 8.5? Well, it hits 8.5 going from here to here. It hits 8.5 going from here to here. And it hits 8.5 going from here to here. But this answer is 1. But if it was 8.5, it'd be 1, 2, 3. The justification on this is really hard to get, or it's really easy to get. If you're going to write everything out, you would need to say that from 0 to 5, the particle is increasing, and if this position goes from 5 to 11, it has to hit every point from 5 to 11, and then it doesn't hit from these because 7 is not between these. It's a lot of things, but what you can say is you can say it's 1 because it hits the intermediate value theorem, IVT. The intermediate value theorem says you can't go from 5 to 11 without hitting every number between there. That's one you want to memorize. It's a very simple formula. It's basically saying if you're going from 5 foot to 6 foot, you've got to hit 5'1", 5'2", 5'3". So it's not really a calculus theorem, but it helps you to keep from explaining. You can just put one time, you put your work right here, or the work right here, because of the intermediate value theorem. Alright? Find the total distance traveled. Let's go, let's hit page right here. Okay. So the total distance traveled, we've already, you should be able to nail this. The particle went up 6, down 3, up 1. Up 1. So it's just 6 plus 3 plus 1. Even though it goes down 3, you count that as a positive distance traveled, so that's 10. The starting position does not matter. It doesn't matter where you start. How do you write this as an integral? Well, you need to write it like this. The integral of the absolute value of velocity. And if you just want to memorize this for total distance traveled, that'll get it to you. And you're just going to write 6 plus 3 plus 1. You've got to write this to get this point because this is a calculus exam. They want to see if you're knowing the calculus. All right? Hope you guys had an awesome weekend and have a good week next week.